Talk about measures of spread, but before we do so, let's go over our previous lesson over histogram. A histogram is like a bar graph that displays ranges of information. For example, this is number of visits to a pool last year. It has a range. These are number of students, number of visits. So number of visits 0 to 9. How many students went to the pool between 0 and 9 times? 5, 10 to 19 times, 3, 12. This is 6, and this is 2. The question is, which interval represents the most number of students? Is that median, mode, or mean, median, or mode? It's mode, most common. So 20 to 29 visits. So 20 to 29 visits represent the most number of students. Which interval has only 3 students? Between 10 to 19 visits. How many students went to a pool at least 10 times last summer? I mean, 10 is the least. Everything has to be greater or equal to it. So, at least 10 times. 3 plus 12 plus 6 plus 2, 23 students. How many students went to a pool less than 10 times? That means less than, below. So that's 5 students. That is a histogram. So, we're going to put everything what we've learned so far together. So measures of center are mean, median, and mode. These are all called measures of center because they describe the data in the center. If you arrange them or solve it, you'll find that most of these are in the center of the data set. So mean, again, is average. It's where you take all the data, you add them all up, and then you divide by how many there are. Median is a halfway point. So you have your upper half and your lower half is right in the center. It's the halfway point. Mode is the most common. So mode is the most common, the number that most repeated. So today we're going to be learning something called range. Range is another word for spread. It's how spread out the data is. So you find the minimum or the least, find the maximum or the greatest, and you're finding out how spread out is it from the least to the greatest or from the minimum to the maximum. And then to find the spread, you subtract it. You subtract the maximum minus the minimum or the greatest minus the least. So, another thing we're going to talk about is something called quartiles. You're going to hear us use the next word quartiles for the next 2 or 3 days. Quartiles is splitting the data into groups of fourths, or 25%. So you're splitting the group into groups of fourths. So fourth, 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 and fourth, or 25% of data, 25% of data, 25% of data, 25% of data. So how do you do splitting them into? So how are we going to represent the data today? What we're going to do is we're going to split the data into quartiles and describe the median of each quartile. So first you put the list of numbers in order, then you cut the list into 4 equal parts. The quartiles are at the cuts. So what does that mean, for example? For example, it means the following. So you have the following numbers. You have 5, 8, 4, 4, 6, 3, and 8. As you see, we put them in order. So here you put them in order. We find the median. The halfway point is 5. This is called quartile 2. This is the median of the whole thing. This is the quartile, or this is quartile 2, or the median. Then you have the lower half and the upper half, because remember, median is the halfway point. So here are the lower halves. Here's the upper half. So in here, what is the median of the lower half? There's 3, 4, 4. The median of the lower half is 4. So this is called quartile 1. And then this is the upper half. So we have the median right here. This is the halfway point. We have the lower half, the upper half. In this upper half, what is the median of the upper half? 8. This is called quartile 3. So this is called quartile 1, quartile 2, quartile 3. That means 25% of the information of the data is here. 25% is right here, 25% of the material of the data is right here, and 25% are right here. So these are the cuts. Is it true? Let's see. As you can tell, there's 4 data. This is 1/4 or 25%, 1/4, 25%, 1/4, 25%, 1/4, 25%. And then the last thing we talk about is IQR. IQR is interquartile range. An interquartile range is the difference between quartile 3 and quartile 1. So you find quartile 3, which is 8. That's the median at the upper half again. Then you find quartile 1, which is the median at the lower half, 4. And then you subtract the two numbers. 8 take away 4 is 4. So the IQR is 4, or interquartile range. You might say, why are we doing all this stuff? Well, in our next lesson, we're going to talk about box plots. Using the quartile 1, quartile 2, quartile 3, and interquartile range, you'll be able to plot a box plot. Some of us in the older past have learned it as box and whisker. Now we call it box plot. So, yeah. So, I'm sorry, I already skipped over 8. So interquartile range is the difference between quartile 3 and quartile 1. So this is quartile 3, quartile 1. You find the difference. 8 minus 4 is 4. So let's practice this out. So we have all these numbers. I would like you to put them in order from least to greatest. So let's see. We have 62, 63, 2 64s. Let's go to 70. So we have 70, 72, 76, 77. And then we have 2 81s. So find the median or quartile 2. This is the first split. That means we're finding the upper half and the lower half. So do. So what is the halfway point of 70 and 72? 71. So quartile 2 is 71. Let's label this quartile 2. So quartile 2 is the median. Quartile 2 is the median. Is the halfway point. So as you can tell, this is the lower half. This is the upper half. If you want to label it, you can. This is the lower, and this is the upper half. So find quartile 1 or the median of the lower half. So what is the median? What's the halfway point of the lower half? It is 64. So quartile 1 is 64. Guys, this is the lower half. This is the median of it. So what is the median of the upper half? 77. So find quartile 3 or the median of the upper half, 77. So again, let's make sure we understand this. So I found the median of the whole thing right here. This is where 50% goes at. Half of it is below, half of it is above. So this is the lower half and upper half. This is quartile, let's label it. This is quartile 1, and this is quartile 3. This is the median of the lower half. This is the median of the upper half. That means 25% of the data is right here. 25% is right here. 25% is between quartile 2 and 3. And then above quartile 3 is 25% of the data. So there's 2, 2, 2, 2. It is. So the next thing is find the IQR or the interquartile range, the range between the two quartiles. So we take quartile 3, which is 77. We take quartile 1, which is 64, and we find the difference of it. So find the difference. So quartile 3 minus quartile 1, so 77 minus 64 is 13 is the interquartile range. Let's try another example. We have some information here. Put them in order. 5, 8, 10, 10, 15, 18, 23. So find the median. So here's the data. Find the median. That's quartile 2. That halfway point. That 10 is quartile 2, or the halfway point. That means 50% of the data is lower of it. 50% of it is upper of it. This is the upper half. This is the lower half. Find quartile 1 or the median at the lower half. 8. Quartile 1 is 8. So the median of the lower half of 5, 8, and 10, the halfway point of the lower half is 8. What is the median of the upper half? 18. Quartile 3 is 18. So again, why are we doing this? You have all this data. 25% of the data is right here. 25% of the data is right here. 25% of the data is right here. And 25% of the data is right here. So we partition or put this into fourths. So a fourth of the material, the data is here, 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 which equals 100%. So in other words, 50% of the material of the data is right here, 50% is right here. Find the interquartile range or the difference between quartile 3 and 1. Quartile 3 is 18, and quartile 1 is 8. So the IQR, or the interquartile range, is 10. That's the range between the two quartiles. Or in other words, it's spread. That's the spread between the two quartiles. So here's a set of data. Let's describe it now. From what I can tell, it seems like find quartile 1. Oh yes, this is completely wrong. They did this on purpose to trick kids. So let's erase this right here. So find quartile 1, quartile 2, quartile 3. So let's start with quartile 2. That's the median of the whole set. Dot, 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 dot. 11 is quartile. That's the median. That's the median of the whole. I mean, this is the lower half. This is the upper half. Find the first quartile, first quarter of it, the first fourth. What's the median of the lower half? I think it's going to be right here. So that's 9.5 is the median. Find the median of the upper half. It's going to be right here. That's 12.5. Guys, dot was between 12 and 13, 12 and a half. Find the range of the whole thing. Range is the spread from the minimum to maximum. 15 is the maximum. 9 is the minimum, so the range is 6. Now find the interquartile range by subtracting the two quartiles, the upper median and the lower median. So the upper median is 12 and a half. The lower median is 9 and a half. If you subtract that, it is 3 whole. So the last thing we're going to talk about is something called outliers. Outliers are a number that lies completely outside of the norm. It lies outside. This is completely off track. For example, if this was about number of times you've been on a plane, most kids look like from here have been, all right, actually couldn't be a plane because this is 1.5. This is a number of, I don't know, how much money you collected in this game. So most of them, you can tell the majority of the kids seem like the cluster right here is between 1.5 to 5. But however, this is 9.5. This person is outside of the norm right here. So that's why it's called outlier. So a new coach has been working with a long jump team this year, and the athlete performance has changed. So here are all the athletes. Which student is the outlier, outside of the norm? So positive, positive, positive. So everybody's jumping more, as you can tell. Oh, except Sam. What? I'm not jumping more? So Sam he actually got worse. Like, way. May have a broken leg or something. Who knows? So Sam is the outlier. In the next one, you have all these students and time taken to run the 100-meter dash. I probably would take 25 seconds. So I would definitely be the outlier. Which student is the outlier? So let's see. 11, 12, 11, 10, 11, 17, 10, 10, 12, 10. Which one is like completely out of the norm, outside a cluster? Frank is. He is completely outside of the norm. Because what happens is when you have someone who's completely outside of the norm, they skew the data. So this person would skew it big time. He would skew it more to the left. But we'll talk about that tomorrow, about that kind of stuff. Skew to the left, skew to the right. Because so he's skewing to the left. So if we take away his data, Frank, then all of this would have changed. All of this information would change. So that's why sometimes outlier hurt the data. Or actually, it manipulates or changes so much. So what did we talk about today? We talk about quartiles. Quartiles are when you have a set of data, you divide. Quartiles is the fourth of each data. So you have quartile 1, quartile 2, and quartile 3. Quartile 2 is the halfway point or the median of entire data. So 50% of the material, or lower half, is right here. Then 50% of the data is up here. That's upper half. So lower and upper. Then quartile 1 is the median of the lower half. Quartile 3 is the median of the upper half. So as you can tell, we broke the data into parts, into fourths, 25%, 25%, 25%, 25%. And then to find an interquartile range, you subtract the two interquartile ranges, which is quartile 3 and quartile 1. And that is measures of spread.